Okay, good morning. This is Professor David J. De Los Reyes. It's good morning here in Los Angeles, California. The time is almost 4:30 a.m. It's February 4. Okay, my topic for this morning, it will be this morning here in Los Angeles. It will be an application problem of trigonometry, and this is a long video. Okay, a long video on the subject matter trigonometry. Okay, let's proceed. I will check my camera first. Oh, it's fine. This will now be an application problem of the so-called concept of trigonometry. I will be showing you this morning the importance of trigonometry in practical problems in real life. Okay, let's proceed. we are given we are given a rectangle over here. Okay, the rectangle is designated by AD up to this point here and up to this point. Okay, inscribed in the given rectangle is actually this right triangle here. The triangle ABC is inscribed in the given rectangle, and the problem said that at this corner here, this side here is perpendicular to this, meaning this is a 90-degree angle. What is also given in the problem is that this is angle theta, and this is also angle theta, and the length of AD is 13 inches. The problem is asking for find AC as a function of theta. AC is actually the length from point A to point C. The problem says that if this is theta and this is also theta and this is 13 inches, what will be the length of AC as a function or in terms of theta? Okay, so the first requirement is AC as a function of theta or in terms of theta. And the second requirement is what will be the length of AC. This is question mark. If the angle is actually 35 degrees, 16 seconds and 16 minutes and 45 seconds. Meaning if this angle here is 35 degrees, 16 minutes, 45 seconds, what will be the length of AC? How long is it? Okay, let's proceed with the solution. To bring out the solution of this, we must have to bring out a right triangle coming from the given figure. So what do we do tonight? The first right triangle that we will bring out is this right triangle ADB. Okay, it is this one here. It is this portion. We will bring out this right triangle here, the one I will show. Okay, and that's it. So we will try to put the designation. This is A, this is D, and this is B. If this angle here is theta and this is theta, I place it here. This angle is actually 90 degrees minus 2 theta. Because this is twice theta, right? So the angle of this should be 90 degrees minus twice this. So that's actually 90 degrees minus twice of theta. So if this is 90 degrees minus twice of theta, supposed to be the other angle is actually twice theta. Because the sum of this angle here plus this is actually 90 degrees. Okay, the sum of this plus this is 90 degrees. Because 90 degrees minus 2 theta plus twice theta should be equal to 90 degrees. That's why I place it here. If this is 90 degrees minus twice theta, this angle should be twice theta. Okay, I will erase this one so it looks very good. So we are now given the designations, right? And from here, let's try to compute for the length of AB. Because if we could compute for the length of AB, we could transfer this AB here on the next right triangle. Okay? We will take sine of 2 theta. We will take the sine of this angle here. Considering this angle, this is opposite side, okay? And this is the hypotenuse. So if we take the sine of 2 theta, it should be 13 all over the length of AB. So I place it here, sine of theta is 13 over AB. And computing for AB, okay, it will be 13 over sine of 2 theta. That's equation number 1. I mark it as equation number 1. When we mark an equation by a number, it means that it is a very important equation, okay? Okay, let's try to bring out the next right triangle from the given figure. I will try to bring out this one, the one I will be shading by green. Because we already have computed this one, AB, as a function of theta. And that's it, equation number 1. So in the computation of the length of AC, we needed this one. That's why we go first for the length of AB. If I will now try to bring out the right triangle designated by ABC, it is this. Okay? This is angle theta. How come this is angle theta? Oh, this is angle theta, right? This is angle theta. And actually, this is AB is actually 13 over sine of 2 theta as computed from the first right triangle. And the requirement of the problem is the length of AC, the length of this. Okay? What will be AC equal to? Okay? Okay, let's try to consider theta. If we try to consider theta, this side here is adjacent, right? And this is the hypotenuse. So if we take the cosine of theta will be adjacent over hypotenuse. So it will be AC, or AB rather, over AC. Computing for AC, AC now will be AB over cosine of theta. We call this equation number 2. Okay? That's equation number 2. Okay, I will check my camera first. Oh, it's still fine. So we are now given equation number 1. We are now given equation number 2. So I place it here. Substitute the value of equation number 1 to equation number 2. What will come out? We will take this value here. We put it on equation number 2. Meaning the value of AB in terms of theta, we put it on equation number 2. So AC will be equal to AB. AB is actually 13 over sine of theta. It is this. Right? All over cosine of theta. And simplifying this one, we are dividing a fraction all over another number, okay? So it will be 13 over sine of 2 theta. Actually, this is actually cosine of theta over 1. Okay? And if we try to change the operation from division to multiplication, we should multiply, okay? Instead of cosine of theta, it should be the reciprocal of cosine of theta, that is 1 over cosine of theta. Okay? We change the operation from division to multiplication. So we will rewrite the numerator, then multiply the reciprocal value of the denominator. And the reciprocal of cosine of theta is actually 1 over cosine of theta. And if we try to simplify this one, AC now will be 13 sine of 2 theta cosine of 2 theta. So actually we are now given, I will change my pen. We are now given AC as a function of theta. And that's actually our answer. That's our answer. Okay? That's the first requirement. Okay? And the problem is asking for what will be the value of AC if theta is 35 degrees, 16 minutes, 45 seconds. So I place it here. Oh, this is the systematic solution if you are on the board exams. Theta will be 30 degrees, 35 degrees rather, plus 16 minutes, 45 seconds. Changing all the terms into degree, it will be 35 degrees. Minutes to degree is actually 16 over 60, okay? Because 1 degree is 60 minutes. So for this 16 minutes to be degree, we divide it by 60. And for the 45 seconds, to convert it to degree, it is something like this. If we divide the 45 seconds by 60, then we will divide it again by 60, okay? And this will now be in terms of degree. So the divisor of the 45 seconds is actually 60 times 60 or 3600. So to change minutes to degree, we will just divide that by 60. And to change seconds to degree, we will divide that by the product of 60 times 60, which is 3600. So using your calculator, the sum of theta will be 35.279 degrees. Okay? And if we are now given the value of theta, we could compute for the cosine of theta. Cosine of 35.279, it will be it's 81635. If theta is 35.279, we multiply that by 2. Twice theta will be 70.558. And if we try to compute for the value of sine of 70.558, it will be 0.94297. Okay? I computed the values of these separately, so when we substitute, it will be the so-called, it is the so-called compressed form. It's nicer to see the equation, right? So AC now will follow this. It will be 13 over sine of 2 theta. Sine of 2 theta is 0.9427, is this. And cosine of 2 theta is 0.81635. And if you try to multiply the product of this, we will divide that by 13. What will come out will be AC equal to 16.8870. So actually, AC is 16.887 this length here. Meaning to say, if this is 13 inches, and the problem says that this is theta and this is theta, what will come out for the value of AC will be 16.887 Okay guys, that's the so-called application of the principle of trigonometry in solving real problems in real life. That's trigonometry. At least we now know the importance of trigonometry. In the so-called practical problems, we needed the concepts of trigonometry, that is the definition of sine, cosine, tangent, and other things. I will check my camera. That's it. So for you guys who are taking trigonometry, okay, this problem is for you. Okay, so if you like my long video tonight, please click like, and if you want to subscribe to my channel, okay. I got 4 subjects in long form videos: differential calculus, integral, differential equation, advanced math. And I am now compressing my topics on trigonometry and algebra for you to have more additional subjects on my channel. If you want to subscribe to my channel is at youtube.com, okay, /@Prof. David J. De Los Reyes. And if you want to share my long video tonight, please click share. Good morning, Los Angeles.